Hello everyone, what I have here is 1, 2, 3 ZX Spectrums. Is this triple trouble? Let's find out. So the first one looks like this, has a bit of super glue in here, the sticker is going out, and yeah, it looks like this. Nothing major beyond that. It came in the box with a Timex 2048 power supply without its power connector. Second one has a very corroded faceplate, but the sticker is looking like new, and it looks like this on the back. So nothing major also. And the third one, that is a more common Sinclair ZX Spectrum, has a very wavy faceplate and very corroded also, and it looks like this on the back. Everything looks nice, has a very well glued rubber feet, but yeah. So these are the three machines that we'll be looking at. This is the first, this is the second, and this is the third. That's how I'll be referring to them from now on. First, second, and third. And let's open them up, make the initial tests, and see how each one is doing after all these years. So let's go. First one. Individual bottles for the screws of each one. Number one first. Whoops. Screw post might be broken inside. Yep, it doesn't sound too good. Yep, broken posts. Yeah, and broken membrane. Yeah, first membrane. It's very well broken. Okay, we have an issue too. This is a broken post. Most of the caps don't look bad, but this one has just two legs connected, and I need to check this. There's obviously some kind of mod that has been done in here, and yeah, apart from this, everything looks normal. To remove this screw, I'll carefully use a pair of pliers to hold it from this side and unscrew it from this side. There we go. Then we can glue it later. Bottle number one. This side of the board looks like this, and this side of the board looks like this. Yep, membrane is fully cracked. We'll need a new one. So, machine number two. Very corroded screws. Hope there's no liquid damage here. So let's... Who glued it? Okay. Ooh, very badly broken membrane inside. Yep. This membrane's dead too. So two membranes. Ooh, and this has some liquid corrosion. Some humidity has been around here because this is all green and there's a piece of membrane stuck inside here. So I think I can remove it with a pair of yes, it worked. White sockets. These ones are nice. I have never seen white sockets before. Yeah. So this is an issue 3B. There's a screw missing inside, but all the rest it looks okay. Most of the caps look okay. It just looks like it has seen some kind of moisture at some point in its life, so this one needs a very good clean. Yep, yes, it's a bit oxidized and has a very dry looking on the side of the board. So yeah, it has even reached the speaker, so the speaker is also dirty. Yeah, this one will need a good clean and some reflow of the solders. So yeah, this side of the board looks like this, and this side looks like this, and this is board number 2. So another membrane and another board to test. So let's go for number 3. So here is ZX Spectrum number 3. Let's open it up. Let's open it slowly to see if cracked membrane right from the beginning. Yeah, you can see there that yeah, it has some kind of very tight bands, and it's cracking. 3 cracked membranes. So let's try to pull it out carefully, even though it looks cracked. This is an issue 4B. All the chips are soldered except for the ULA. Yeah, as you can see, this membrane is cracked and has some kind of bubble. Yeah, it's completely cracked, you can see it. So, well, I've done it before with good looking membranes on this area. I've managed to solder wires to the membranes. I don't think I'll do it this time because it's a pain in the ass to do it, but I might save one of these membranes to try and do a video about it. Yeah, this one looks brand new. Everything is okay. No caps are spilling. Everything looking good. So yeah, on this side of the board everything looks like new. Only this TR4 transistor looks like it has been reflowed or something, but everything is looking fine. So this side of the board looks like this side looks like this, and this is number 3. So let's test the boards and see what we get from each of these ones. So I've done the major tests on all of them, and the only worrisome thing that I can see is this like crack on the top of this ULA. I don't know that if this is from manufacturing or if this ULA has really a crack on the top. So I'll check the ULA for shorts, and if nothing looks suspicious, we'll test it. Multimeter in continuity from ground to the ULA. We will need to have a ground on the top right and nothing else. So I don't see any shorts. Let's power all the boards up and see how they are doing. So let's test ZX Spectrum board number 1. It boots. This one seems to be working. Let's do the full diagnostics. Jesus, that scared me. So let's see. Sound is working fine. All tests passed. Yep, everything seems to be working fine. So this board is okay. Let's test the next one. So, Spectrum board number 2. Let's turn it on. No image. We have no picture. Yep, power consumption is okay, but we have no image. Let's see if we hear any sound of the diagnostics. Nope. And it looked pretty dead. Yep, no signs of activity. All the power supply voltages are okay, but yeah, we have no signs of life out of this computer. So it might be something like ULA or CPU. My first bet is on the Z80, but we will replace the socketed ULA just to test right now. Yeah, everything looks dead. So out goes the ULA. I'll grab another one. New ULA in. Live! So there's big probability that this ULA was dead. Let me just repair my jig for composite. Or can I? So, new ULA in. Let's test. Still no image. Whoops. Yeah, we have some kind of image. Yeah, but we have also a total lower RAM failure. No way. I said also because on the TS2048 that I'm doing a video on, it's also a total lower RAM failure. So we will have 2 computers on the channel with this total lower RAM failure. So now we know that this ULA is okay. The data lines are pulsing okay. So yeah, that's another thing to fix. So let's test computer number 3. ULA and lower RAM. Yeah, and the broken ULA is the one that I've shown you before with that crack on the top. Yeah, this one is definitely dead. So here we go for computer number 3. Let's see what it does. We have an image and yep, Sinclair Research. So this one seems to be working fine. Let's see if it passes the diagnostics. See if it produces any sound. Yep. Everything seems to be working fine. So let's see if it detects all the RAM. Yep, everything is looking good. So this machine needs only the recap. Yep, perfect. So all 3 computers have been tested. First and third computers are okay. The second one needs a new ULA and needs the repair to find what's wrong with the lower RAM. So let's investigate. So here we are around our number 2 ZX Spectrum that had the ULA replaced and lower RAM trouble. So on the image we have a full lower RAM failure, but I think that would be very unlikely. So let's try to do some troubleshooting to see if it really is all dead chips, or some of these multiplexers is dead, or if we have some kind of interference from the upper RAM or one of these logic gates. I see that this IC has been replaced in the past, so I might assume that this is okay, but I will take it out and test it anyway. But the first thing that I will do is to remove all the stuff that is socketed, especially all the upper RAM, and see if it changes anything on the behavior of the computer. Let's remove. Don't do it like this. Yeah, it survived the fall without any mangled pins. So let's remove them all. So all lower RAM chips are removed, and I will also remove this logic gate. And let's test. Let's see what it does. Yeah, we have the exact same result. So testing this yielded the same result. We have a full lower RAM failure, but all the voltages are okay and all the data lines and functions are working properly. I will just check with the multimeter if we have the correct voltages here on the lower RAM, and we have the 5 volts, we have the 12 volts, and we have minus 0.47. That might be slightly corrected after recapping or something. Yeah, but I don't feel any of the chips heating up. All of them are relatively cold. So my main suspect would be something around the CPU or the two multiplexers that make the major communication between this, the ULA, and the CPU and ROM. So let's take the heatsink out and have a look at those chips. Maybe we should take them out and test them on the IC tester. So let's take this out and see if we can find anything wrong in there. Yep, there's a genius work in here that I found on lots of other Spectrums. That is putting a washer between the power regulator and the heatsink. There's a washer in there. Why do people do this? I really don't understand. Why are you insulating the voltage regulator from the heatsink? Look. Yep. There's a locking washer underneath the voltage regulator. This is dumb stuff. Okay. Rant aside, this board is looking a little bit too much dirt for my taste. It has a lot of oxidation and lots of pins. As you can see in the back, this is looking a bit sad. And here, of course, this is just dirt that has no impact on the function of the board. But let's have a look and see if there's anything wrong around here. And let's try to power this thing and see if any of these become hot or something. Yeah, but yeah, my bet is maybe one of these. So let me just correct one thing. I was looking at the schematic, and the two ICs that I will be replacing first are these two, because they are directly connected to the lower RAM, and these other two are interfacing with the upper RAM also. Let's take them out and see if there's anything wrong with them. So this is the first chip out. Let's test it. So I've put the chip on the tester and voila! Everything is wrong with this chip. So first shot, first bird. So I don't know if I just got lucky, but the first chip we replaced is actually bad. So I have a new chip here. It's the only one I have, so if we have another one broken, I'll need to buy another one. But every time you change one of these chips, it's very important that you put a socket in it, because it will help to replace the chip later if you need it, or it will make troubleshooting the future problems a lot easier. I'll try to find something high enough to hold it in place. And for testing, we will clean all these pins that we had put new solder in, just because we might as well only have one bad chip. So we will test with only one chip replaced. So let's solder the new socket. First, I'll just solder the corners and yeah, adjust the socket position, because it was very tilted. Now it will go into position, and this thing burns the fingers on the other side. Yeah, new socket in place. Let's solder it. And now I need to do one thing, that is bend slightly the pins of the chip for it to fit in the socket. You can see that this is another Portugal made chip, and let's put it in the socket. So everything fits nice and snug. And we are now ready to retest this. So the screen is on, and I'm now ready to power on the computer. So everything is looking good. Whoops. This thing didn't sound quite well. So nope. Black screen, black border. No way. if we boot into the 16K mode, it now boots into the boot screen. So the CPU is working, the ROM is good. Yeah, now we have some extra problem.
A few moments later.
Let me just check that everything is well inserted. No bad contacts. Oh, yeah, it was just a bad contact. Yeah, this thing is super dirty. I should clean it. I shouldn't even be using my tools on super dirty connectors. But yeah, I'm a lazy bastard and I should have cleaned it before. Now I will have dirty contacts on the tools and dirty contacts on the computer. But yeah, I'll deal with that. So let's see if it tests good. Image is okay because I know this ULA has shifted graphics. So it thinks it's a 16K spectrum. Let's just check. Yep. Everything seems to be fine now with the computer. Let's put the upper RAM back. So let's see if it now works with all the upper RAM installed. Nope. There's some problem with the upper RAM. Okay, lower RAM problem solved. Now we have another problem. And it says all the upper RAM chips are dead. What? Come on. Yep, that's a curious problem. All the upper RAM chips are dead, but these ones are socketed and they have an external RAM test board. So I will take some of these ICs. I'll pick the first two ones. So I will grab the RAM tester and test these two ICs to see if they are good or if there's something wrong with the multiplexers or logic gates that control the upper RAM. Yeah, this one is testing good. Let's check the next one. Yeah, it's also good. So probably all the RAM chips are okay and there's just something wrong. Maybe this chip that was replaced. Might be something wrong with one of these or one of these. So we got lucky in the first try. Let's see if we can diagnose on the second try. First, I'll test this one that is socketed and see if we have some results from this one. Yeah, nothing new here. This one tests good. I don't want to do gambling, so let's try to diagnose where should we go next. And for that, I will need an oscilloscope. So I will try to probe the signals around and I'll get to you if I find anything that's suspicious. So I'll be right back. So I've been probing around as I've told you before on the 74 LS32, and I've been probing around this 74 LS157, and I know that the output of these two chips are pin 4, pin 7, pin 9 and pin 12, and I found that pin 7 on the IC26 is outputting a weird signal. So I will turn the computer on. I will show you what a good signal looks on pin 4, and now I will show you what a weird signal looks on pin 9, and it's not reaching the 5 volts that are needed for the logic to work well. So if I look into pin 9 here on the other IC, it's looking completely different. So I might try to swap this chip first. So I'm sorry because this is still doing some bad contact, but yeah, I'll take this one out and let's see what it tests like. None. Yes. It came out beautifully. No lift up traces. Everything is looking good. So, sure enough, after testing, yep, this chip is not okay. So let's replace it. So this is another LS157 defective. We have already 2 from this machine. I'll put a socket in its place, but I will have to go and source another one because I don't have any in stock. So let's put the socket in and I'll wait for the chip to arrive. Nice. Nice. And just for curiosity, let's see what kind of error we get without the chip in place. Yep, exactly the same error. Let's go. So I went to the store and bought some new chips. Let's put it in place, and without turning it on, I will just check with the oscilloscope if the signals in pin 7 are already different. So let me see, 1, 2, 3, 4. In pin 4 signals are fine. 5, 6, 7. Yep. Pin 7 we have good looking signals. So let's connect to the screen and see if the test passes now. What do you think it will happen? I think the computer will be fully functional. Let's see. Okay, we have a big improvement. Will it pass everything? Yay! Computer is fixed. Yeah, and the oscilloscope helped us a lot, because on the first one it was a lot of luck, but in the second one, yeah, the scope told us which chip was bad. Nice. So the spectrum is fully functional. Yes, let's go. So now I will do the recap on all the 3 boards, and we will start reassembling the computers, cleaning them, putting new membranes, and doing minor repairs on the faceplates, and then we can test them for games. So let's go. So I hope you enjoyed this troubleshooting video. This is the end of the part 1 of a 2 video series. On the second video I will treat the aesthetic part of the computers, and I hope that you can join me to see how they turned out and hopefully to play some games. So thank you very much for watching, and I'll see you in the next one. Bye!